Okay, so if we've got a system of equations here, let's consider no solution. If there's no solution, it means our lines are parallel, but our y-intercepts have to be different. Okay, so first things first, let's consider the two equations and work out what the gradients of these two lines are. So if we just label the first equation as line 1 and the second equation as line 2, and rearrange those, we'll get y is equal to, take that whole term over on the other side, so we get 2 minus, in brackets, leave the brackets, m minus 2x. And for equation 2, let's take the mx across to the right hand side, then divide by 2. And that will give me k minus mx, each of those over 2. So now it's in the gradient intercept form. So remember, for parallel lines, the gradients must be equal. So that means the gradient of the second line, for example, or the first line, negative m minus 2 has to equal negative m on 2. So cancel out our negative signs and probably take the 2 on the right hand side and the m on 2 back to the left hand side. We'll end up with a half m is equal to 2, and so m is equal to 4. So that says if m is equal to 4, the gradients will be the same. So the second part of for no solution is the y-intercepts have to be different. So in that case then, if we look at the two y-intercepts, we get 2 is not allowed to be equal to k on 2. So if I multiply the 2 across, that leaves me with k not allowed to be equal to 4. So to get no solution, which means the gradients are the same and the intercepts are different, I have m equal to 4 and k not equal to 4. Therefore I get parallel lines, or lins as it says. Let's consider part B. We've sort of done the hard part of it all now. So for infinitely many solutions, the gradients need to be the same and the y-intercepts need to be the same. So we've already worked out where the value of m needs to be for the gradients to be the same. So again, we will have m is equal to 4. And now in our y equals mx plus c, we want the same c value. So m is equal to 4, and this time the constants will be equal to. So instead of k not equal to 4, we'll have k equal to 4. So by rights, if m is 4 and k is 4, if we check that back into those two equations, we should get the same lines. So substitute that back in. So if I put m equal to 4 into equation 1, I get 4 minus 2 in brackets x plus y is equal to 2. And then if I put m equal to 4 and k equal to 4 in equation 2, I get 4x plus 2y is equal to 4. So the first equation simplifies to 2x plus y equal to 2. The second equation, if I divide by 2, becomes 2x plus y equal to 2. So the equations are the same, so I get infinite solutions. Part C, a unique solution. A unique solution means they just intersect. So all we need to have for that is a different gradient. Doesn't matter about our y-intercepts. Our y-intercepts can be the same. We just need a different gradient. So if we know that for m equal to 4 the gradients are the same, what we need is m not equal to 4. And the k value can be anything. So we might write k as an element of R, which we may have seen, but really what's that saying is that k is an element of the real numbers, which means k can be any value or anything.